As we continue talking about linear functions, linear equations, one of the characteristics that we find are of linear functions are going to be parallel and perpendicular lines, and the relationship between two lines can be determined just by comparing their slopes and their y-intercepts. So we have parallel lines have equal slopes because the slope is constant, so that way they never touch. And then, of course, intersecting lines have slopes that are not the same. And then you have perpendicular lines. And with perpendicular lines, your slopes are opposite reciprocals. And we're going to go into working these out and trying to figure it out. But two lines on the same plane, if they have the same two lines on the same plane either are parallel or they intersect. So if they have the same slopes, they're parallel. If they do not have the same slopes, that means they intersect somewhere. And we're going to talk about that and work with those characteristics. So here, writing an equation of a parallel line, a line passes through a given point of -3, -1, and is parallel to the graph of y equals 2/3 x minus 1. What equation represents the line in slope-intercept form? What equation represents the line in slope-intercept form? So they're asking us to create an equation of a line in slope-intercept form that passes through that point. And in doing so, we need to have slope-intercept form. We have y equals mx plus b, and we are not given either m or b in this case. So what we can do is, if we want it to be parallel, we've stated that parallel lines have the same slope. So if I come over here in my line that I'm parallel to, the slope-intercept there is going to be the slope of that line is going to be 2/3. So I know then that I'm going to be using the slope of 2/3. And I can do some substitution now, and I can say, okay, well, y equals 2/3 x plus b. Now, I don't know what my y-intercept is yet, but they have given me these values of x and y. So what I should be able to do is, I have three variables now. Y equals 2/3 x plus b, so I have y, x, and b. I should be able to do some substitution to eliminate some of those. So they've given me a value of x, they've given me a value of y, so I can substitute my y and x in here, and that leaves one variable left for me to solve for. So in doing that, I know that, I know that here's my x, here's my y, so I do some substitution. So y is -1. -1 is equal to 2/3 times x, which is x is -3 plus b. And now I can simplify. I have -1 is equal to 2/3 times -3 is going to give me a -6/3, which is also the same thing as -2 plus b. And then to isolate b, right, I'm still trying to get b by itself, I add 2 to both sides, and I have b then is equal to 1. Okay, so if b equals 1 and then my slope equals 2/3, I actually have enough information now to write an equation in slope-intercept form. So I just need to replace my m and my b. And in doing so, my m was, we said 2/3, my b is going to be 1. And there you have it. We have a new line that passes through this point, is parallel to this line. And we know that it's parallel because it has the same slope and two different y-intercepts. Y-intercept of -1, y-intercept 1. So they are parallel to each other. So we don't need to graph it yet. We'll worry about graphing it on the next few problems. So let's see here, going here and classifying lines. And, well, we know to classify lines, parallel lines have the same slope. Perpendicular lines have opposite reciprocals. And then neither. So if they're neither opposite reciprocals nor the same, they're just lines. And we'll have to explain. So one way to begin doing A here is to, let me clarify, opposite reciprocals. Opposite reciprocals. So if I have 2/3, because we've used that slope, the opposite reciprocal would that be, the reciprocal would be 3/2, and the opposite would be negative. So we went from a positive 2/3 to a negative 3/2. That is an opposite reciprocal. And if you wanted to test it, well, if we multiply those two things together, we get -1. So if my slopes, if I multiply my slopes together, they equal -1, that's an opposite reciprocal. Typically not a skill that we are using until later on in Algebra 2, but if you understand by definition what a reciprocal is, what the opposite is, that's all you need to know right here. So, coming back down to classifying these lines, I have two lines, and they are not in the same form. So if I'm going, what I want to do is I'm going to get this line, well, I have first y equals 3/4x plus 7, and 4x minus 3y equals 9. And in order to figure out if my slopes are the same, I need to get them to where I can read the slope easily. So I'm going to go ahead and convert this second equation here into slope-intercept form, and I'm going to do that by isolating the variable y, so it is y equals. And in doing that, I am going to go ahead and subtract 4x from both sides, so I can start by isolating this term, and then there we go, 4x minus 4x is going to give me 0. I'm going to have -3y equals -4x plus 9. Now I'm going to continue to isolate my y by dividing by the coefficient. And when you divide one side, you must divide the entire other side. So -3 over -3 becomes 1. So I have y is equal to, negative over negative becomes a positive, so I have 4/3 x minus 3. 9 over -3 is going to be -3. So here's my second equation in slope-intercept form. And then my first equation, so we can see it a little bit better, is y equals 3/4 x plus 7. And my question here is, do we have the same line? Do we have the same slope? We do not have the same slope, so that means they're not parallel. They're not parallel, slope does not equal. You know, my m is not equal. Now, are they opposite reciprocals? Well, if I have 3/4 and I multiply that times 4/3, it should give me a -1. Well, they are reciprocals. I can just look at this and tell you, hey, it's a reciprocal. 4/3 is a reciprocal of 3/4, but it is not the opposite reciprocal. So it's not perpendicular either. You know, it's not perpendicular, so it's just going to be neither, because they are two equations of a line. They have slopes, but they are neither parallel nor perpendicular, so they are going to intersect somewhere along the coordinate plane. Now, if we go through and work this next one, doing the same thing, b, if we take b and we go to slope-intercept form, I need to divide both sides by 6, so that is going to be y equals -1/6x plus 1, and the other one is y equals -1/6x plus 6. Well, look at that. My slopes are the same in these two equations, so if I have the same slope, hopefully we know that that equals a parallel line. And then in geometry, you know, parallel lines are, you know, use those two little hash marks like that to indicate parallel line. So we are able to look at those and identify if they're perpendicular, parallel, or neither. Okay, now writing the equation of a perpendicular line, let's see here. So a line passes through this point of 1/8 and is perpendicular to this guy right here, y equals 2x plus 1. What equation represents the line in slope-intercept form? Okay, well, if this is the line I want to be perpendicular to, well, that slope that slope is 2 over 1, and in order for it to be perpendicular, it has to be the opposite reciprocal. So my reciprocal, my perpendicular slope is going to be the reciprocal and then the opposite. So instead of my slope was a positive 2, the opposite reciprocal will be a negative 1/2 slope. So my new equation of a line is going to be y equals some slope plus my b, and we just said that my slope was going to be negative 1/2. So I have negative 1/2, and again, if we go back to that example we did just a minute ago, 2 minutes ago, 3 minutes ago, I have 3 variables here, y, x, and b, and I am able to substitute in my x and y into this equation. So if I do some substitution, y is 8, and that's going to equal negative 1/2 times my x value, which is 1, plus b. And then I'll go ahead and simplify. I have 8 equals negative 1/2 plus b, combine like terms, add 1/2 to both sides, and then b is going to be equal to 8 and 1/2, or also 17/2. Depends on which one you're more comfortable with. I'm definitely more comfortable with 17/2. So when I do this substitution up here, I get y equals negative 1/2 x, negative 1/2 x plus 17/2. There we go. That's the equation of a line. Equation of a line that is perpendicular to the given line. And let's see here. Next, solving a real-world problem. An architect uses software to design the ceiling of a room, and the architect needs to enter an equation that represents a new beam, and this new beam will be perpendicular to the existing beam, okay, and which is represented by the red line. So we're trying to find something that is perpendicular to our red line in our image here, and the new beam will pass through the corner represented by the blue point. Okay, so this blue point right here, the beam is going to pass through that and be perpendicular somewhere along the lines of this. And perpendicular, we know, is going to be 90 degrees. And it says, what is the equation that represents the new beam? Well, this point is what? That point is the same thing as x value of 12, right? Up to 10, so I can rewrite that as 12/10. So I know that x is going to be equal to 12, y is going to be equal to 10. So I know that y equals some value x plus b. Don't know what my b is yet, but I do have some ordered pairs that I can fill in. And what else do we know? That, well, I know that my slope should be equal to the opposite reciprocal of the red line. So if I count the slope on this line, quickly I could say, well, my rise is going to be going up 8 and going right 12, or in this case, going down 8 and right 12. So slope of this line is rise over run, so that is negative 8 over 12, which is going to be negative 2/3. So the opposite reciprocal of this is going to be 3/2. Positive 3/2 is the opposite reciprocal of negative 2/3. So this goes over here. So I have y equals 3/2 x, 3/2 x plus b, and I can do the same substitution I did before. I can substitute in my values of x and y. So I have y is equal to 10, 10 equals 3/2 times 12 plus b, and 10 is going to be equal to 36 over 2, which is 18 plus b, minus 18 on both sides, minus 18 on both sides, and then b is equal to negative 8. So do some substitution. the equation of that line is going to be y equals negative 8x plus, got ahead of myself, is going to be 3/2 x minus 8. And that's the equation of a line. And let's see here, and I guess that would make sense that if you drew this imaginary line through here, my y-intercept is technically going to be down here. So yeah, that seems to make a little bit of sense, so the equation of a line. And just as a reminder, our parallel lines have the same slope. Parallel lines have the same slope. Perpendicular lines have opposite reciprocals, and then if they don't have parallel or perpendicular, they intersect somewhere on the coordinate plane. And then opposite reciprocals, if we multiply one slope times the other slope equals -1, those are opposite reciprocals. But anyway, we'll talk more about that later.